Hi, this video will be a brief overview of the concepts covered in Chapter 1. Many of the concepts covered in Chapter 1 should be a review of the research methods course. In research methods, you discussed independent or predictor variables versus dependent or outcome variables, and hypotheses as statements regarding the relationships between independent and dependent variables. In this course, we'll focus a lot more on the null hypothesis. In research, the null hypothesis is always present, but often implicit. It's rarely stated explicitly in published research, so it is often overlooked in discussions of the scientific process. But it's the null hypothesis that gives research its power. Without it, everything that we do is sort of meaningless. It's the null hypothesis that we'll test in statistics. So why is this null hypothesis so important? Both inside and outside of research, data collection and observations are guided, at least in part, by assumptions. Outside of science, these assumptions are often unchecked, like we see with the confirmation bias. So for example, I assume that emergency cures colds. So in case you don't know, emergency is just these little packets of vitamin C powder. And every time I get a cold, I drink a lot of emergency and I get better in about 3 days. I take this as evidence that the emergency is working. So my research or my alternative hypothesis is that there is a relationship between the emergency and cold symptoms, and that emergency reduces the cold symptoms. But think about what my null hypothesis should be. The null would be there is no relationship between emergency and cold symptoms. Most people get over colds in about 3 days, regardless of using emergency or not. So it's entirely likely that I would have gotten better, even if I didn't drink the emergency. So it's entirely likely that the data actually fits the null hypothesis rather than my assumption, my research hypothesis. So what I need to do is next time, actively test the null. Next time I need to not take the emergency and see how long it takes me to get better without it. From a scientific perspective, what I could do is take a group of people with colds and give half of them emergency and give half of them no emergency and compare these two groups. I could measure symptom severity or cold duration. My research hypothesis would be that the emergency group will have a shorter cold duration compared to the no emergency group. And my null hypothesis would be that the two groups have the same cold duration. If we think about the levels of measurement for our variables in this study, my independent variable of emergency would be nominal. There are two groups. One group gets emergency and the other doesn't. I could label my groups as experimental and control. So those who get the emergency are my experimental or my treatment group. And those who don't get the emergency, they are my cold group. I could alternatively give them numbers to serve as labels. So the emergency group could get the number 1 and the no emergency group could get the number 2. But these numbers would just serve to distinguish between groups. Their numerical value is meaningless. I could just as easily use 88 and 95 instead of 1 and 2. It's sort of like zip codes. If you have a zip code, it's used only to distinguish geographic regions. The numbers don't really mean anything. So if your zip code is higher than mine, it doesn't mean that your region or area is better or greater. It's just different. So we belong to different categories, and we can't use those numbers for the purposes of comparison. They're just merely labels for these different categories. Let's look at our dependent variable of cold duration. This would be a ratio level variable because there is a meaningful zero. We know what 0 days of cold symptoms mean, right? It means that you don't have a cold. Plus, we can compare using ratios. So if your cold lasts 2 days and mine lasts 4 days, then my cold lasted twice as long as yours. If we compare that to the interval level of measurement, here, these don't have a meaningful 0 point. So think about, for instance, a satisfaction scale. Even if you marked that you had a satisfaction level of 0, what does that mean? Does that mean neutral? Does it mean unsatisfied? Does it mean actively dissatisfied? It's difficult to determine what that 0 would mean in this particular instance. And so that would be an example of an interval level of measurement. And we can't really compare in terms of ratios. So if you have a satisfaction level of 1 and I have a satisfaction level of 2, we know that I'm 2 points higher in satisfaction, but we don't really know that I'm twice as satisfied per se. With ordinal levels, these aren't common in our field. We don't typically encounter ordinal level variables in psychology. But with ordinal levels of measurement, cases or attributes are rank ordered. So think about valedictorian and salutatorians. The valedictorian had the highest GPA. The salutatorian had the second highest GPA, but we don't know how much higher the valedictorian was. In some classes, it's razor thin. Right? It might be the difference between a 4.0 and a 3.99. And in some classes, it may be the difference between a 4.0 and a 3.5. So the differences separating valedictorian and salutatorian are not standardized. So coming back to our null hypothesis, it's the recognition that my assumption may be wrong. I predict that there is a relationship between emergency and cold symptoms, but I acknowledge that this prediction may be incorrect. Ultimately, we collect data or observations and use statistics to determine whether our observations are better explained by the research alternative hypothesis or the null hypothesis. With statistics, we're putting our assumptions to the test. Only those assumptions that withstand this test, those that are supported by data and the numbers, are given proper consideration. And so that's what we'll be doing in this class, right? Is learning more about those statistics that we use to describe data and to test these assumptions.